Dear students, now let's we understand clipping above reference voltage, that is nothing but clipper circuit, parallel clipper, series parallel clipper, clipping above reference voltage. Okay, let the voltage be clipped off to say 2 volts. Here V naught max is nothing but 2 volts and V naught max is equal to Vd plus V reference. V reference is equal to V naught max minus Vd. Here Vd we need to select V naught 0.6 or 0.7. V reference is equal to 2. You need to substitute V naught max value 2 minus 0.7. V reference is equal to 1.3. If in case you substitute Vd is equal to 0.6, you will going to get V reference is equal to 1.4. Here I got 1.3. Okay. This is a circuit diagram, series positive clipper with positive biasing, clipping above reference voltage V reference. Okay, this is nothing but a signal generator. We need to set 10 volts peak to peak, or as per the given question, we need to set input signal and input frequency 1 kilohertz and 10 volts peak to peak, or whatever the question they are going to mention, you need to set the input value. Okay, next this is nothing but a diode IN4001 and resistor value 3.3 kilo or 10 kilo, 1 kilo, you can select any one value. Next 3 volts reference anta ide, you can select according to our calculation 1.3 or 1.4, and ground output voltage. Okay, this is the expected output waveform. The 2 volts should be clipped off. V naught is equal to Vr. Here in the negative off cycle, V naught is equal to Vi. Whatever there is in the negative off cycle, that will going to reflect in the output side. So we need to concentrate on only positive off cycle. Okay. Now let's we get into the breadboard connection. Here, as per the circuit diagram, I made the connection diode, resistor and connecting wires. Only here we are going to use two components, diode and resistor. 1 kilo ohm resistor I use, and this is nothing but a RPS. Here we have two sets. Okay, I'm going to use this set because it is nearer to the breadboard, so it will going to avoid the extra wires. And this is nothing but a CRO. This is a digital storage oscilloscope, so that's why this is a digital storage oscilloscope, DSO. And input and output waveform, I already got the output. I'm going to let you know how to check the output. And this is nothing but a signal generator. Here we need to set frequency. I already set the frequency for 1 kilohertz, and voltage 6 volts peak to peak, or as per the question we can set 10 volts peak to peak, 9 volts peak to peak, whatever it may be, we can set whatever the value. Okay, here also I need to set 1.3 as per the calculation. And as per the circuit diagram, I'm going to set 10 volts peak to peak here. How to set 10 volts peak to peak? I need to increase the value for 10 volts, and I'm going to check the value here, input value, only input value. I'm going to check first input. Okay, okay. Now let's we concentrate on only input. Only input. Okay, what is the input value? Here the total input value 5 volts per division. Here the waveform will going to cover two boxes, so that's why two boxes, the waveform will going to cover two boxes, so two boxes into voltage per division, 5 into 2, that is nothing but a 10 volts peak to peak. We can check here also 10 volts peak to peak. Measure here also we can check 10 volts peak to peak, 10.2 volts peak to peak. Now let's we concentrate on output channel. We need to set to the AC. Okay, yeah. Now this is a positive parallel clipper, so output voltage should be clipped off up to 2 volts. Now I'm going to check whether it clipped off or not anta. Yes, of course it's clipped off. It covers only one box during positive cycle. 1 into 2, 2 volts clipped off. Okay. Now I'm going to check the transfer characteristics. How to check the transfer characteristics? Just go to the display and select XY. Now I'm going to get transfer characteristics. This is how we need to operate and check the output waveform in the DSO, digital storage oscilloscope. Okay. Thank you so much.